Okay, good afternoon, pilot teachers, and good afternoon, students. Okay, thank you. Sit down. Our lesson today, I'd like us to look at least the formation and explanation of how rapids and also interlocking space are formed. And as I've mentioned earlier on, that from what I am giving in terms of those features which are formed at the first stage of a river valley, you will also be expected to do the same for the other features associated with the second and the last stage of a river valley as a group work for presentation. But let's look at rapids, formation of rapids, and also formation of interlocking space today, as those constitute for some of the features which are found in the first stage of a river valley. To recap on what we have covered so far, we have looked at the study of rivers in 3 sections, and I mentioned that rivers can be actually divided into 3 parts. The first stage of a river, of which vertical erosion is dominant. The second stage of a river valley, of which lateral erosion is dominant. And the third stage, of which deposition is dominant. In the first stage of a river valley, these are some of the features which are common. Features such as potholes, waterfalls, rapids, and interlocking space. We had time to actually look at the formation of potholes and also the formation of waterfalls. To recap on the work we did on waterfalls, mentioned that waterfalls occur where the bed of a river becomes suddenly steepened. Waterfalls are of 2 types. Number 1, those caused by difference or differences in rock hardness in which the river is cutting, and those caused by uplift of land, lava flows, landslides, and etc. We looked at the waterfalls which are caused by differences in rock hardness into which the river is cutting. And there were 3 different types that we looked at in our last lesson. They are: 1, when a layer of hard rock referring to rocks which resist erosion, lies across a river's course, the soft rock on the downstream side are more quickly eaten into than into the hard rock. The riverbed is thus steepened where it crosses the hard rock, and a waterfall develops. A waterfall arises when the hard rock layer is horizontal. A waterfall arises when a hard rock layer dips gently upstream, and a waterfall can also be created or is formed when a hard rock layer is vertical. And to look at the diagrams showing the 3 different examples, we have the first diagram here showing us the hard rock layer which is horizontal, the black color representing that. Here we have a waterfall created. The second example, where the hard rock layer dips upstream, the dipping of the rock layer upstream can also give rise to the formation of waterfall. And finally, where the hard rock layer is actually vertical, it can give rise to the formation of waterfall. Okay, and that is what we have actually looked at on the development of waterfalls. I'd like us to move on today to looking at the formation of rapids and also the formation of interlocking space. We will start off with rapids. And here we have a collection of a photograph or a picture just generally showing us an example of what a rapid would look like. For those students who have been to the Crystal Rapids out of Port Moresby, then you know exactly what a rapid looks like. It would look like a series of steps, and you have water falling from one layer to the next layer to the next layer, and etc. Like when you have the steps itself of a building and then you let water to flow through. And when you have water falling from different layers of rock from one stage to the next, then that can also give rise to development of rapids. We'll need to understand how rapids are formed, and for us to be able to do that, let's look at generally the structure of rocks, how they are laid for the formation of rapids. There are 2 ways in which rapids can develop, and the 2 ways are: 1, A rapid develops when a waterfall of type 1 and type 2 above, or what we have looked at already, retreats upstream. Let's recall, waterfalls can be formed in 3 different ways. 1, when the hard rock lies horizontally. 2, when the hard rock dips upstream. And 3, when the hard rock is vertical. Okay, for a rapid to develop, it tells us here that a rapid develops when a waterfall of type 1 and 2 retreats upstream. That is one way in which rapids can be formed. And the second way in which rapids can be formed is where a hard rock dips downstream. I will explain each of those so that perhaps it can make it a little bit more clear what we mean when we say a waterfall of type 1 and 2 retreats upstream. Okay, I'll give you at least 1 minute perhaps to make note of that information, and we'll go over to the explanation of those 2 ways in which rapids can be formed. Okay, have you made note of that information? Okay, let's look at the first information given there, and it tells us that a rapid develops when a waterfall of type 1, which is rocks, hard rocks lying horizontally across the riverbed, and type 2, of which the hard rock is dipping upstream, retreats upstream. It might seem a little bit confusing because you're looking at the retreating of water upstream, and we know that the law of gravity does not allow the water to flow back up to the high areas. Water will always flow from high altitude areas to the lower area. But here we are saying that a rapid can be formed when a waterfall of type 1 and 2 retreats upstream. That is not to say that the waterfall is going to flow back. No. That information is telling us that the retrieving, or in other words, if we are going back from where the waterfall is towards the source, then we can come to the different stages at which, before the water falls from this particular area to that area, a rapid can also be formed. And this is not to say that the water is actually moving back up. No. I've already mentioned that if we say that, then we are breaking all the laws of nature. It's impossible, will not happen. Rivers or streams will always flow from high area with the help or aid of gravity down towards the lowland area. You can never have rivers flowing from the lowland area up to the mountains. Impossible. So with this statement, don't get this confused and say that the water is moving back. No. Waterfall of type 1 and type 2, if we are looking at the stages in its development and we are going back to originally how the water is flowing, then along the way, in the beginning stages, we can come to looking at the development of rapids before the formation of waterfall. The difference between the waterfalls and the rapids is in terms of the height in which the water descends vertically. A waterfall, the height in which the water descends is actually greater than in comparison to the rapid. Okay, that is one difference perhaps that you are able to pick out. Okay, with that information here, you have the arrow here. This arrow represents the rapid stage, and here you can see these 2 diagrams here to represent the formation of rapids. Then we have this arrow going from this point here all the way to that point to show us the stages which contribute to the formation of the waterfall. Okay, I have placed number 1 here to showing the waterfall because we are interested in looking at the development of rapids. So if we look at that information, a waterfall of type 1 and 2 retreats upstream. That means we are staying from where the waterfall is and we are coming to the area upstream. So we start off from here. In this case, you have the water falling from this distance to that distance is greater. This cannot be a rapid. This is a waterfall. But at the same time, bear in mind that you have the soft rocks, of which it is represented with the dots that I have put here for each of those diagrams, and the lines here representing the hard rock. Okay, for this diagram, note the arrow coming from this end to this end telling us that the undercutting of the hard rock layer causes waterfall to recede upstream. Stage 1, then we come to this stage here. You will see the distance is getting shorter. We come to the next stage. The distance from this point to that point should be shorter than that, and etc. Until finally we come to these two diagrams here, 5, 6, 7, and 8. And for 7 and 8, can you see that the distance in which the water falls is actually very short in comparison to at this point? And this is where we have the development of rapids. So when we look at a waterfall of type 1 and 2 retreats upstream, this is exactly what we mean in terms of how I've put the information on this diagram. Any questions? Any questions? And again, I'd like to remind you that don't be thinking that it is the water which is falling back, because if we are thinking about water falling back, then we are developing a wrong concept, because we know that water will always flow from high areas down to the low areas under the influence of gravity. And if we are going from water flowing from here up, then we are breaking the rules of nature and the law of gravity also. Okay, if there are no questions, then we'll move on to the second way in which rapids are developed, and that is simply by looking at the way in which the hard rock is actually laid along the riverbed. Remember, when we were looking at the development of a waterfall, especially in the second diagram, I mentioned that the hard rock dips upstream. For the development of a rapid, the hard rock dips downstream. If the hard rock dips upstream, then it will not form a rapid. Rather, the feature that will be produced will be a waterfall. But if we have a hard rock that dips downstream, then obviously a rapid can be developed. Let's look at the diagram to go with the second explanation. The water is actually flowing down in this direction. Same for the second diagram. You have the soft rock. On the second diagram, the soft rock. The black area here represents the hard rock. Note that the dipping of that hard rock is actually downstream. If it was dipping upstream, then I would turn that particular black area around so that most of it is actually pointing up rather than down. So the bottom part of it here will be pointing upstream rather than downstream. So the second way in which a rapid can be formed is the way in which the hard rock is actually laid on the riverbed, and it is the laying of the hard rock dipping downstream. That then can give rise to the development of waterfalls. Okay, I'll give you at least a minute. Maybe you might want to make note of that diagram also, the two diagrams. And that will also be the information that I'd like you to know about in terms of the formation of rapids. The two different ways in which rapids are formed. Questions? Any questions at all with regards to those two information? No questions? Okay, if you don't have any questions, then we will move on to the next feature, and this time looking at the formation of interlocking spurs. Shall we move to the next feature? Okay, this time we're looking at interlocking spurs. We are now leaving rapids. And for interlocking spurs, note the information now on the monitor will help explain how interlocking spurs are formed. It states there that vertical erosion rapidly deepens the valley. And when that is happening, it also gives rise to V-shaped valleys being created. The river, if it is following a channel through those valleys or through the valley, will twist and turn around obstacles of hard rock. So in other words, when the river is actually flowing through the channel, where there are areas of hard rock, those hard rock areas will act as obstacles, and that means the river has to work its way around those hard rock. Therefore, erosion is actually pronounced on the concave banks of the bend or bank, and this ultimately causes spurs which alternate on each side of the river to interlock. Okay, I'll go through that information again. Vertical erosion rapidly deepens the valley. That is in the formation of interlocking spurs. The river twists and turns around obstacles of hard rock. Erosion is actually pronounced on the concave banks of the bend or the bends, and this ultimately causes spurs which alternate on each side of the river to interlock. Okay, for those students who are still making notes on that, you can do that quickly and we'll move on. Okay, more information with the formation of interlocking spurs. Note there the undercut concave banks would usually stand up as river cliffs. Meanwhile, on the opposite convex bank or banks, there is little or no erosion. Therefore, the banks on the convex side would usually form gentle slip-off slopes. On the bend where erosion is actually effective or dominant, then what is created are river cliffs. Meanwhile, on the opposite bend or bank, there is little or no erosion, and the bank would usually form gentle slip-off slopes. If I had to show that information, perhaps in diagrammatic form. Okay, I'm looking at the bank, which are the sides of the river, we know that. And the flow of the river is the bed. The arrow from this illustration here shows the flow of the water in this particular channel. So the river is flowing from this end and around the bend. These are the bend. One bend here, there's the next one, and etc. as we're going down, following the channel in which the river is flowing. See where the water is actually flowing. Which side, A or B, do you think the water will hit hard? A, obviously. And that's where erosion will be effective, on this particular side or bend, resulting then in river cliffs being formed. Meanwhile, the opposite of this will be the B side. On the B side, there is little or no erosion. Therefore, what feature is created? Yes, the slip-off slope. Okay, and that's what that statement is actually making reference to. The river flows. Because the river is coming in this direction, according to the bend of the bank of the river, the water hits hard at this particular bend, erosion is effective, therefore it creates the river cliffs. Meanwhile, on the opposite side, little or no erosion, therefore what is created here are the slip-off slope which are formed. And here we are looking at the formation of the interlocking space. As the river continues on flowing, one slope then interlocks to the next, to the next, to the next as it is actually traveling down. And therefore, when we look at the diagram to illustrate that, then this is what it would look like. This is a spur interlocking with this next spur here, interlocking with the next one, with the next one, the next one, and etc. On the bed, that's where the river is actually flowing. Where the water hits hard on one side, you have the undercutting, which then will result in cliffs being formed. Meanwhile, on the opposite bank, no erosion, slip-off slopes are actually formed. And this is what an interlocking spur would actually look like. And they are common features in the first stage of a river valley. Questions? Any questions? Okay, if I ask you the question, how are river cliffs formed? What would be your answer? Noel, how are river cliffs formed?
River cliffs are formed from the undercutting of concave banks.
Very good. Can you explain what concave banks are? What are concave banks? Ebony, what are concave banks?
These are the bends where on each side of the river, but the river erodes that side more.
Okay, not on each side of the river, because it could also mean each side or either side here or there. So we are looking at least along the bend, on one bend where erosion is dominant. What do you call the other bend where there is little or no erosion and slip-off slopes are formed usually? Mason, what is the term that we use to describing the opposite to the concave banks?
Convex.
Convex, good. And in the convex bank, there is little or no erosion. And usually, the slip-off slopes are formed with the formation of interlocking spurs. And that's important because when we look at the second stage of the river, this is still going to be important, but instead of the formation of cliffs now, we'll have erosion, continuous undercutting. Meanwhile, on the opposite bank where the convex banks are, that's where deposition is going to be dominant. But this comes in the second stage. This is to do with the interlocking spurs, therefore the formation of river cliffs and slip-off slopes. Okay, now we'll go to doing some activities. And there are 3 activities that I will assign you to work on. The first one, you'll have to double check now that you understand or you've understood how rapids are formed. You are asked now for activity number 1 to explain with the help of a well-labeled diagram the formation of rapids. And there are 2 ways that we have looked at on how rapids are formed. That's activity 1. Activity 2, you are required to explain how interlocking spurs are formed. You don't need to construct diagrams, but at least you are able to explain how interlocking spurs are formed. And activity 3 is mainly to do with definition or definitions, and there are some of the words that we have used in our lesson today that I'd like you to also define. And the words are rapids, to define what rapids are, interlocking spurs, to define what they are, concave banks, to define what they are, convex banks, slip-off slopes, and river cliffs. Those are some of the terms that we've used today. It's also important that we know the definition to those terms. Okay, I'm going to give you at least 3 minutes for each of those activities. Is 3 minutes sufficient or enough time? I think most of you have got your notes. You've done your notes when we were going through, so using your notes, you can actually expand on to ensure that the answers are given. Okay, 3 minutes per question. And if there is anyone who needs help in terms of explaining what we have covered, you can raise your hand. I'll come around and see if I can help with the further explanation where you have maybe doubts or queries. That's right. So you have to go to put the maybe an arrow to indicate the flow of water, yes. Okay. That arrow is important. So the way in which the rock is dipping, you know it's dipping downstream. That means if the water is flowing this way, it's dipping downstream. That means Okay, also, we've come to the end of the lesson, and I would like to correct at least activity 3 in our next lesson. That means you ensure you have your answers, and we'll go through the correction of the definitions to activity 3 for the introduction in our next lesson. Okay, so to double check quickly on those words that you're supposed to define for activity 3, the words are A, rapids, B, interlocking spurs, C, concave banks, D, convex banks, E, slip-off slopes, and F, river cliffs. And those words for us to look at the definitions in the introduction lesson or in our next lesson in the introduction part. Okay, you've made note of all of those words? Okay, if you can stand up now, class. To the pilot teachers, our keyword for lesson 74 is rapids. Good afternoon and thank you, students.